So our next panel is on unleashing the potential of non-terrestrial networks and integration. So can I please ask the participants to the stage, and it will be moderated by Isabel Moreau from GESOA.
Good afternoon. Yes, my panelists want to come up. So Mario, who you already know. Also, I have Robert Suber, who you've met this morning from Intelsat, and Gianluca Redolfi, the Chief Commercial Officer of Sateliot. So please join me. Thank you. So we're here to talk about how we're going to unleash the potential of non-terrestrial and terrestrial integration. As you know, non-terrestrial networks, especially satellite communications, are set to change the landscape of connectivity and data delivery. I think we've heard it this morning. The growth we are experiencing, as we discussed, is unprecedented in our industry, and this is mainly due to two factors. One is, of course, the incredible level of innovation that we have witnessed in the last, I would say, 5 years in particular, but also the increasing demand for ubiquitous connectivity around the world. And we do believe that NTN can, of course, provide that ubiquitous connectivity, particularly in remote, unserved and underserved areas, and enabling new application across industries, and also, through broadband internet access, D2D, and IoT. So what I want to discuss with the panelists today, this afternoon, is looking at these opportunities that are ahead of us with this integration of terrestrial and non-terrestrial, and touch upon areas such as standardization, technical capabilities, but also business models and market opportunities that we see out there. And of course, regulatory challenges, which Mario has already spoken about in the context of the WRC 27, but I think, we can go a bit deeper into that conversation. So maybe I'll start with you, Mario. Since you're all warmed up by your keynote, you can continue. One of the things that, maybe we didn't mention in your keynote is that when we look at WRC 27, I think, correct me if I'm wrong, that 80% of WRC 27 is going to about space and satellite. So that tells you, how much work first Mario and his team is going to have for the next 3 years, but also us as an industry. This is really unprecedented, I think, as well. And of course, it reflects the growth that we are experiencing and the innovation in the market. But if we look more at really the NTN and TN integration, Mario, what are the main regulatory challenges that you foresee when you think of this integration, and in particular when we think of also 5G and 6G? So, what is what keeps you awake at night, and what do you hear from member states as well?
Well, thank you, Isabel, for the question. Yes, I mentioned that 80% of just a clarification here, of the agenda items of the conference are related to space and science, to satellite and science, so that means to space. I say that because that doesn't mean that 80% of the work is going to be related to that. I had some comments from the mobile community saying that what they have to do is less number of agenda items, but very, very complex. So it's not about work or about amount of effort. It's just about the number of agenda items. Huh? So 80% of the agenda items, number of agenda items, is related to space, which shows really what the trends are, as we said. So I think there are several challenges when we think about integrating non-terrestrial networks and terrestrial networks. But before getting into that, I would like to distinguish between the two main approaches in integrating these two networks that the industry is currently developing. So one approach is to integrate in a single user terminal a terrestrial equipment operating in frequencies allocated to the terrestrial mobile service, and a satellite equipment operating in frequencies allocated to the mobile satellite service. So this is what, for example, Apple and Globalstar are doing. The other approach is the one that we have all thought about from the beginning, is to ensure that both non-terrestrial and terrestrial networks can be used by a single user equipment operating in traditional mobile bands. That's, for example, what SpaceX is doing with T-Mobile. So in the first approach, the main challenge is that you have to design a mobile user terminal that contains, in effect, two different terminals. So the Apple phone is a complex terminal, and it has these two components. The upside of it is that there isn't any regulatory or any operational issue or challenge, because there is no frequency overlap, since the solution works by using different frequency bands that are already allocated and licensed to the mobile and mobile satellite services. Okay? So the focus of the studies are going to be for the second approach. So in the second approach, the challenge are both regulatory and operational. On the operational side, how to ensure that the satellite signal does not interfere with the terrestrial signal, either at the edge of the coverage or at the edge of the spectrum blocks. And on the regulatory side, how to frame the usage of satellite system overlaying its signal in bands heavily used by mobile system without interfering with the signal the satellite is intending to complement or the other terrestrial signals that are adjacent to it. It's what I said in my presentation. So you are using terrestrial bands, IMT bands, but you are, let's say, orienting your antenna upwards. So how do you ensure that there is no interference? So this second approach is the one that is being studied, is agenda item 113 of WRC 27, and it will consider the possible new allocations to the mobile satellite service, taking into consideration all the bands that I showed you in the highlighted box, which are the frequency bands for IMT listed in the recommendation ITUR M1036. So there are other challenges, of course, that are of commercial nature, roaming agreements, economic viability, challenges intrinsic to the propagation delays and latency related to maintaining the quality of service, the challenge of mobility management between terrestrial and non-terrestrial networks, but all those other challenges are beyond the remit of the ITUR. Thank you.
Thank you. And you know, just want to follow up on that because you know, at a time where I thought I was very optimistic, at least to see that, you know, mobile operators and sort of the mobile industry and satellite industry will come closer together. And particularly, you know, we signed an agreement, cooperation agreement with the GSMA at Mobile World Congress. From what you're seeing already now in the WRC discussions, do you foresee that now the sort of discussions are going to intensify, or do you think that finally we are seeing a path where it's inevitable that we have something that we will need to share one way or the other?
Well, when we started talking about D2D, I was as naive as you were, thinking that now satellite operators and mobile operators were going to stop fighting and just partner in order to provide this service together. But it is not as simple as that, because many of them are thinking of doing them by themselves. And it's possible. So depending on what the conference will decide, it will become possible. So I think the fighting has maybe decreased a bit, reduced a bit, but it's not stopped. And we have another fight, as you know, which is between GSOs and non-GSOs. So the fighting apparently is the new mood, unfortunately. But let's hope that it will get better.
And for those who don't know me, I come from the 15 years in the mobile industry at GSMA, so, you know, I was sort of brought in to put amends, and, you know, I'm trying my best, but it's proving quite challenging. But Robert, let's move on swiftly to, Mario mentioned the commercial sort of opportunities. So as we talk about this technology that continues to evolve, this integration, how do you think businesses can best position themselves to leverage this integration? What are the sort of business models that we are seeing, the type of partnerships? And how do we ensure that between, let's say, the mobile industry, for instance, and satellite, there's going to be a real level playing field in terms of benefits, and it's not going to be one party takes it all?
There's a lot to unpack there, but let me do my best. I'm going to bring a slightly different angle to the conversation. Yours is very much focused on D2D, and we understand those variants quite well. But what Intelsat has been doing specifically to support our mobile network operators is to take fundamentally a different strategy. And that is that what we are doing is, if we all agree that 5G or 6G and that future direction is consistent with any form of NTN or NGN philosophy, then we will be adding a great deal of benefit to mobile network operators globally. Now, let me explain that. With the advent of our strategy, which emerged a few years ago, we were positioning the launch of software-defined satellites, which could create an enormous amount of flexibility for our mobile network operators, being able to put power where they needed it, when they needed it. Now, coupled with that, what was very important to make that succeed was a software-defined network, which was 5G standards-based. So if you have a ground segment which is communicating in 5G wavelengths, and if you have a satellite which is operating based on open standards, there will be a complete change in the industry. It is a game changer. I mentioned this morning electronically steerable antennas, those devices at the organisation. If I could leverage the recent press release which we did based around what we did with SoftBank, it is exactly that model where we will be building a 5G satellite network which ultimately allows, let's assume it's a motor vehicle, to traverse a 4 or 5G terrestrial network, and as soon as it's out of that range, it will immediately switch to satellite, maybe LEO or GEO. And to that end, what we are doing is bringing broadband to those vehicles by having a GEO and LEO mix, which is true 5G or 6G in the future. You'll be able to have 100 megabits delivered by LEO, 30 or 50 megabits by GEO, CIR, MIR mixes, and it will be able to really provide the solution which the MNO is seeking. Now, we've got to remember that the MNOs are under a lot of stress. We've seen them under enormous pressure thanks to OTT over the years with 4G, and now moving into 5G and 6G, they're concerned about the hyperscalers taking more of their economic benefit. So they're looking to organisations like Intelsat and the greater GEO satellite industry to contribute and find new ways of monetising this remote edge of the market. Our model is, I think, in a lot of ways complementary to D2D, and I think it will just add more income streams for our MNO customers.
Good, and I think you mentioned it this morning on your panel as well. Beyond the business model, beyond everything else, let's remember that the most beneficiary of all this should be the end user. And this integration should really be seamless. So you shouldn't, you mentioned this morning that it was the seamless use of roaming from a GEO to a LEO to a MEO. I believe it's really important that a customer doesn't even know or realize they shouldn't care whether they are going to pass from a satellite to a mobile use. We shouldn't know, but it should be affordable, right?
So our go-to-market will be the mobile network operator. The end user at the end of the day will not be aware at all which orbit they're traversing. They will have a single experience with a single invoice at the end of the day from their mobile network operator.
Yeah.
Nice and simple.
Good. Gianluca, you are, in a way, Satelliot is in a new business, which is providing IoT via satellite. What does it mean exactly? You know, what does it mean? How does it work? And what sort of market is it going to impact the most? Because I guess it's a B2B business, right? Your customers are businesses.
Well, I would like to put it in the right context. Listening also what Mario and Robert were saying. So we believe that a technology really exists when it can be widely adopted. So if you go back to the 50s, you would ask people to have a computer. They would say, well, no, but a computer were existing, okay? But nobody had a computer until probably the 80s, and then now everybody has 1, 2, 3, 4, 5 computers because we have a computer-in system everywhere. And if you go back to the 80s, mobile telephony existed, but was really for few people. And the key thing that always happens is that standardization of the technology makes it very, very, very affordable and therefore available. What happened with the mobile telephony in the 90s killed completely any other technology on the same service. So what we are convinced is that standard is the way to go. And standard is the only possibility where a customer can really profit from a very, very affordable way of being connected whenever there's no coverage. Okay, there are two ways to do it. Okay, a way is, okay, I don't change the phone or the IoT because I can simulate I'm on Earth, but actually I'm on a satellite. Or, as we are seeing also happening, we see on the new Snapdragon of Qualcomm, quite relevant. We saw it now on Samsung. We saw on the Google phone, on the Pixel, that there's a kind of dual mode that has two different technology in the same handset. So all in all, this is going to make it absolutely inexpensive for the final customer, which is the only important thing. Without getting to the technical aspects, is it Geo, MEO, and LEO, not forget LEO, and all the, which frequency, is it possible or not possible? That's the key thing. So for us, so we're setting up our own constellation, we launched it already, we extend the coverage of the telecom operators, we are a standard, of course. Actually, we initiated in 2019 the discussion of the release 17 NTN. We've been the largest contributor in release 17 from the satellite world. Our business model is wholesale with telecom operators, so we are a kind of B2B, but the customer behind it are business and can be also consumers. And somebody could say, okay, this is a niche thing. Well, everything is a niche until it is not anymore. Okay, maybe having a smartphone at the beginning of 2000 was a niche, and now everybody has. I think, more and more everybody wants to be connected. Everything wants to be connected. So there's a huge ecosystem of IoT existing that is connected to cellular. There are many stats. You can say 1 billion, 2 billion, 3 billion, whatever billions are connected through cellular now. And those, they want also to be connected outside the coverage.
And I think when you look at currently, IoT, there are billions of things that are being connected. I think the opportunities, as you say, are sort of endless, limitless when we look at the future. I think I'm looking at the team here. I think we need to just want to look at the question that we are on Slido. What are the key factors that will enable non-terrestrial networks to have considerable impact on connectivity? Technological advance, standard harmonization, or policy framework? Wow, standard harmonization, yeah. And I think that's very critical as well when we see the advances in 3GPP in particular, as you were mentioning, both of you, release 17, we've really seen the impact that had, and now the implications of the satellite industry being also at the nascent phase of 6G, which is being different from what we saw in 5G, where we sort of jumped on the wagon as it was already started. But for 6G, we are really there from the native stage of technology. Well, yeah, that's growing even further. So very, very clear. Let me maybe ask, going back to you, Mario, given the sort of the complexity that we've heard about the spectrum allocation and the regulatory challenges that we heard about this sort of integration of technologies, what are the steps that you think regulators should take to create a more favorable environment for this integration? And what do you hear from your member states? Where is it that you think you can advise them best?
Well, I think that from the spectrum allocation at the international level, I believe that the regulators are already taking the right steps to create this favorable environment for NTN. If we look at the agenda of the next WRC, we see that there are 3 agenda items related to MSS, one on direct-to-device, one on IoT, and the last one on generic MSS allocation. So they are taking the necessary measures in order to allocate spectrum for NTN. In this study cycle that has just begun, as I said, the regulators can bring their needs together with those of the satellite industry to the ITUR study groups and share their concerns so that they can assess the technical feasibility and the international level and find the right solutions. That could be it could include potential new frequency bands and regulatory mechanisms. This is the way it has been for decades, and it has worked so far. What I want to make clear to everybody is that while all these studies are going on, and the WRC 27 has not yet taken a decision, there is a temptation to test these services, or even to start limited operations. And we know that, and we've seen that. So in this regard, the regulators have a clear responsibility, and they have to be cautious when authorizing these tests or these pre-commercial operations in advance of the decision of WRC 27, because this will be in derogation of the current radio regulations, and then they could cause harmful interference to radio stations of other administrations. So I'm not saying that this cannot be done, because within their territory, the regulators can do whatever they want, but they have to be careful because they can cause harmful interference to other administrations and cross-border coordination problems. So until the WRC 27 takes a decision, those pre-commercial authorization or test authorizations should be done with a lot of caution.
Yeah, and I think it's a good reminder as well of the importance of cooperation between our industry and bodies such as the ITU. It's not a jungle out there, so we have to obey by the rules. And I think it's we're doing a tremendous work, I hope, together, to bring the industry with a position. But Robert, just going back to, maybe the really connectivity and the power of NTN integration in terms of connectivity, how do you see that this integration will really transform connectivity in remote areas that, are unserved, underserved? And what is your company, what is Intelsat's strategy in doing so? And do you think there are metrics that we can use to truly see where we've been successful in a few years' time?
Apart from talking about use cases, I think one thing that, as you were asking me that question, I was processing, and I went back to what Terry said at the beginning of today's event, and that is that the next APSCC conference will be held in Taiwan. Taiwan is also known as the home of chipsets and semiconductors. And I bring that up because as part of the standardization remark on the slide, we saw that 3GPP, I mentioned it earlier, I believe it's really the industry's campfire. It's what we really need to kind of work towards collectively to achieve change. And One of the greatest things that happened, I think, for the geo industry in the latest release was the endorsement of KU band frequency for end-to-end purposes. So with that endorsement, the collective industry has access to about 3.3 gigahertz of that spectrum. Now, if we can go to those important stakeholders in our ecosystem, such as the chipset manufacturers in Taiwan, and convince them that the geo industry has got great ideas for the non-terrestrial network markets, for the unconnected markets, to assist mobile network operators, and convince them to start building chipsets at scale with KU band frequency, all of a sudden that cost that has been quite high for remote terminal usage will begin to decrease. So when we talk about the opportunity, or the opportunity to create inflection and really start penetrating in those remote markets, we've put some of the major building blocks in place right now, which is extremely exciting. But we as a collective industry need to get out there and meet with these mega manufacturers and say, get behind us. Let's start building cheap chipsets. Let's get behind 5G, 6G wavelengths. Let's stop being proprietary. And all of a sudden, the market will open up for us. So when we talk about the opportunity, it is substantial. I've read consultants' reports which suggest by 2033 we'll see over 2.1 million 5G terminals out there. And Asia Pacific will be home to over 34% of that. So the opportunity is staggering.
Yeah, and I do agree that this region, it's quite amazing. Even from my days in the mobile industry, where you saw the most staggering figures, was always, in this region, of course. But Gianluca, to go back to, you mentioned, that we need scale to be successful. You talked about going from a niche market to a mass market, as we saw in the past. So what is your strategy as Satelliot to go, from that niche to the mass market? And in particular, which areas of society or of the economy do you think, IoT via satellite is going to impact the most? Whether is it healthcare, is it financial services, agriculture, all of those? What are your views on this?
Look, I think that the key thing to have scale is basically almost or no change in the final device. Okay, going to Taiwan and asking to include other frequencies or change in the devices or chips is very feasible, but at the same time the cycles are very long. Okay, so the scale should be on being able to use the current devices, especially no change in silicon, no change in the hardware, and make that working with the new solution that provides connectivity outside the coverage. Okay, and we saw there are two ways. One is simulated from sky, and the other one is with a different firmware on the device. So we are, and actually there's something that we saw in the last years. In Mobile World Congress, I never saw somebody from satellite. Now people are there. I was in Mobile World Congress in Vegas 2 weeks ago. There were many satellite companies that are present around. I wouldn't say with the booths, but they were very, very, very present, and the other way around. So this is fusing. This is getting all together. For us, we're going to start now with the IoT. We are building the constellation. So with the piece of constellation we have now, we can offer not real time, so coverage everywhere, but not all the time. So that's very suitable for use cases of IoT. And over time, we're going to get to real time, and this is going to be for any type of application. Use cases are the ones that already exist. There's unlimited amount of use cases that currently are digitalized in the world, because if you don't measure, you cannot get it better. So more and more, everything is measured everywhere in the world, from the top countries to the countries we don't think are top, are very digitalized in every single continent. So we expect this to be getting to any type of use case in the next 3 years.
Thank you. I think we have some questions there. I look at you 2-3 more minutes. There is a new company that claims Bluetooth from space. Is this actually possible? Anybody who wants to take that?
Yeah, well, I can take if you want. So it's true. There are some companies. There's one quite known actually in Silicon Valley that is actually. It's not that they're claiming that they do Bluetooth from space. Instead of setting up a new device, they can format and re-put another firmware on the Bluetooth that are already available, and they can pick up. It's just one way from the satellites. But to answer the question, is it actually possible? Well, we should ask them. They proved it, and we're going to see what's really possible. I can say one thing, that my experience, interferences are very high in general. On licensed bands also sometimes. So using unlicensed bands on Bluetooth to connect from the sky to a small device, it's a challenge.
Thank you. I think we have time. Can I take one more? Robert, that question screams at you, I think. Why do you think direct-to-device will be so profitable in the future, considering the lack of success from Iridium and Inmarsat?
Well, look, first of all, I think Inmarsat and Iridium have been successful companies in their own right. That's the first thing. Why will it be successful? I've seen forecasts suggesting that, again, by the end of a decade, this business is going to be worth $400 million, etc. I think that there's never been so much energy and conversation around this topic. The fact that we're seeing an alignment of the industry, the fact that we've got so many new entrants in this space, the fact that it's occupying 80% of your time, Mario, suggests to me that it will succeed. The one thing about our industry, it happens to stick its head in the sand and deny and say it's never going to happen. Even Starlink, we were saying for years it's never going to happen. How can that business case work? How could it possibly take effect in our industry? Well, it does. Change happens, and they will succeed.
Excellent.
If I may?
Yeah.
I think the simple answer to that is that you are going to use your same phone. So who is going to say no to this? You have your own phone and you are connected anywhere because there is no lack of connectivity anywhere. If there is no terrestrial network, you are connected via satellite. For Iridium or Inmarsat, you needed a satellite phone, which is another device, which is heavy, which is costly, so nothing to do with the business model.
As long as we also get the price entry point correct, right? Because the affordability is going to be a major factor of success. Just to conclude, one word, what is the key factor you think that is going to make a successful integration of this NTN and NTN? If you had just one key factor, what would it be?
I have two.
Two.
Because one is the one that we saw in the answers, which is the standards for the interoperability of the NTN and NTN. But I think there is also the regulatory aspect. I think if we don't harmonize the frequencies that we use, and if we don't stick to the radio regs, then it's not going to work either. So I would say both, regulatory and standards. And I agree with Robert that the ITU has done a great job in detailing the specification of the satellite component of the radio interface for IMT 2020, which is what we call 5G.
Okay.
Thank you.
Gianluca.
Well, of course, those are two important points. From the customer point of view, it's using the same device, so they don't need to buy a separate device, and make it very affordable. Okay, and this is, of course, has to be backed by a constellation that can be profitable at low cost.
Yeah. Robert?
My parting words are that I think as we head towards 2027, 28, these are going to be extraordinary years for our industry, as the latest of these standards are verified, or ratified, I should say. As the satellite industry, especially the GeoSat industry, we've got access to some amazing spectrum, which I think if we can repurpose it for the NTN market opportunity, we'll start making some great gross margins again. So I think we've got this finite spectrum, this finite asset. Let's put it to work.
Thank you. And just to conclude, I think from my point of view, I think we still have 2.6 billion out there of people that are still not online. I believe this has happened because neither one side of the industry or the other on its own has been able to connect these people. And so really, I think magic happens when you bring the strengths of both industries together. And I hope in 10 years' time, we'll be sitting here with 0 people that are still not online. Thank you so much. Thank you very much. And thank you to all of you for participating. Thank you.